Okay, so as usual, I'm recording this class. As I will, like the other classes, I will connect it to this main page here, as I have the last 3 days connected the videos that I've recorded for this class. After this week, I'll also put those recordings, links to those recordings in our weekly journals, so that if you need them next week, if you want to review something, you can find the videos there as well. So I'll also put links to the code directly. So if next week when you are working on your final project, you think, ooh, I'd like to get a hold of some of that stuff that Mr. Walks did last week during remote learning, hopefully it should be really easy for you to find. And remember, I'll be here to help you as well, okay? All right, so yesterday, what we did was we built this design, a very simple design with 4 picture boxes on it. The 4 picture boxes will represent the characters in our game Pac-Man, 1 ghost, a dot, and 1 wall. Obviously, if this was a much larger version of a final project, we'd probably put in lots of walls, lots of dots, and more than 1 ghost maybe. And then maybe other things as well to maybe flesh it out. And then I know it doesn't have to be Pac-Man, it could be whatever kind of game you imagine. And in addition, instead of maybe just doing picture boxes with colors filled in, you might put actual pictures in there. And then maybe, like you've seen in some of the other stuff I've shown this week, you could even animate those pictures, right? So now that you know about timers, you could use a timer to slowly change the picture or quickly change the picture, depending on kind of what you wanted it to do. So just all that potential's there for these extras. They make use of the code from the units that we've already studied. So I'm just going to jump over to the code here. So yesterday you obviously saw that we started by making variables, right? So it's helpful to understand variables so that you can apply it to something like this. That's why the course went the way it did. Okay, you have to build up those skills to get to this point in the course where now, to me, is the most fun part of the course, where you get to actually make something finally that you have the skills. This is, I would compare this to like playing hockey. You can't just go out on the ice and play a game of hockey. You got to learn to skate, you got to learn to stick handle, you got to know the rules of the, doing some fire drill testing, you got to know the rules of hockey, and then you can get into the game, right? Or I could make an analogy to music. Like, it'd be great to stand up and give a guitar concert, but you got to learn the chords, you got to learn how the guitar works. I don't know how guitar works, but those are the things you need to sort of build those skills first before you can do the really cool stuff that you're building towards. Well, we're there now. You've learned about variables. So this was yesterday. We made a bunch of constants to represent up, down, left, right, and stopped and escape. And then I mentioned that we will be using today these variables to track the position of these particular objects, right? So when you imagine a Pac-Man, it's going to be drawn at this spot. Now, this would be something that you would, in geometry class, call its XY coordinate, right? Like this little dot right here. That little dot would be its XY coordinate, right? Like, in what I mean by XY is, like the whole Cartesian. Okay, but then you got to think, well, it's a little more than drawing it that way. I'm also going to need to draw these things, right? The width of this thing and this thing, the height of this thing. So once I have its width and its height and its all that, I should be able to draw it. So instead of doing it that way, oops, did I just type something? What we are going to do with ours is, instead of using those words, we're going to use words like this. This will be the top of this particular thing. Right there will be the top. This will be the bottom. This will be the left of where Pac-Man is, right? And then obviously the width right there and the height right there, right? So this is the height, this is the width, left, right. So all these coordinates will allow us to know exactly where Pac-Man is. And why is that important? Because at some point we're going to have a ghost out there as well. And the ghost will also have its own coordinates. And if we notice that those coordinates are overlapping, then those two objects are colliding with one another. And that's what we call collision detection, to detect if that's happening. So anyways, we made top, bottom, left, right, width, height, and all that. We also in our design use this thing called a timer, which I introduced to you on Monday when we did our media player example. The timer is like a loop, so it helps from the looping unit. And I often find in this course, a lot of students have trouble putting loops in their final project, but have no trouble putting timers in their final projects. So that's good, because when we talk about it next week, the marking sheet for the final project, you don't have to put a loop in your final project. But if you use some of these extra stuff, it can account for even more points. So it can make up for it. All right. We also dealt with this thing called pressing the key down, which was a new thing I showed you guys in the design. So that instead of using buttons all the time to control this mini Pac-Man game, we're actually going to use the keyboard to control it. Okay, and this should be all commented. If you need this code, if this code is eluding you and you do want to try this example either today or next week when you guys are back to school, if you go to our class 20S examples page, the examples for 20S, right? Just like we had the examples for the variables unit and the looping unit, and even all the way back to the beginning of this course, in unit 2, the little, program that just hello, goodbye type stuff. All that code's been building up. And now in the extras, here was the example from Monday and Tuesday, the media player. And here is going to be the code for this miniature Pac-Man game. All right. So that's where we're at. So as of yesterday, I told you there'd be 3 parts to this. So let's start with part 1 right now. How are we going to deal with part 1 of this? Well, before we do that, we're going to be moving Pac-Man around. So we're going to add another variable, but this isn't a big set of variables like these 6, right? Those are 6 variables we needed for all our things. We're going to need just one variable to track movement, because we're going to need to remember which direction our Pac-Man is moving. Now, I'm going to call it Pac-Man direction. That's going to be the name of this variable. What type of variable could it be right here? Be a string variable? Could it be an integer? Could it be a double? Could it be a Boolean? Well, any games where you have things moving, the more movements you have, the more complicated the game is, right? So that's something you got to be aware of. If you're going to have some kind of game where there's 360 degrees of direction, that's going to need a lot of math, a lot of circle geometry and stuff like that. So hopefully you've been taking the right math courses to know how all that math works. This is Pac-Man. There's really only 4 directions that Pac-Man can go. So we don't really need a whole bunch of math here to figure this out. We can kind of simplify it down. So I'm going to just use a simple integer to keep track of Pac-Man. And when this game starts, he starts off stopped. Stopped is a value we made yesterday, which represents the number 0. It also shows you yesterday why we made these up, down, left, and right. We just made 4 simple directions for this to work, okay? So this game has that simple 4-directional type thing there. So I don't really have to do a whole bunch of trigonometry and geometry and find out sine and cosine and all that. You definitely would need to do that if you were doing a little more of an advanced game. We had multiple directions and angles and all kinds of cool stuff. Okay, so we're going to start him off stopped. And now we can actually go down to this key down code, and we can actually add a little more code to this. Okay? Just before we do, I'm going to also add one more constant up here. A constant for how much Pac-Man will move. And by the way, this usually actually isn't always a constant. Sometimes in games, the amount a character moves changes, okay? This can create effects like acceleration, right? If you think about it, I know a lot of you guys are learning to drive, when you accelerate your car and you're going 40 miles an hour, right? That's a measurement of distance over time. 40 miles, that's the distance. Over time, that's an amount. That's a division on a fraction. And then when you accelerate, you're changing either the distance or the time, right? So one of those is changing. So sometimes the amount you move isn't a constant value, it's a changing value. But we're going to make, again, this is a really simple Pac-Man and just move it 5 pixels. All right, so back to key down. Else if. So here you can see from our unit 4, the conditional statements unit. Not only are we writing an if statement, but we're using something from part 2 of that unit, the else if statement. So what we can say here is else if key e dot key value equals the key for down. So here again is where it's really handy that we had made those constant yesterday. I don't have to go up to the top of my code and look at, well, which key represents the down arrow key? It's stored in a constant for me. So I can just type it like it's a word. This is a word. I created the word. So if they press the key down, then Pac-Man's direction equal to move down. This is also one we made yesterday. So that whatever number that represents, I'll just know that the direction Pac-Man's supposed to move is down. All right. Now, the next thing I'm going to do is I'm supposed to, when I press a key down, make these movements. And this is an if statement. But now that you guys are a little more comfortable with if statements, hopefully, you might remember from our unit if statements, I said if the code inside the block of an if statement, block is the code between 2 curly brackets, is only one line of code, you actually don't need the curly brackets. So I could do this with the if statement just to save a little space if I wanted to. But I also said if you want, you can actually even move that line of code up so it's on the exact same line as the if statement itself. So with a little bit of extra spaces, this is maybe another way to look at this code, okay? If the key values end, shut down the application. If the key value is the key to press going down, then I want Pac-Man's direction to be moving down. And now through the power of copy paste, I can do all 4 directions. Down, up, left, and right. Okay. And similarly over on this side, I can say left and up. Now, you don't have to write your if statement like this. Okay, in no way would I be looking for this. In no way does this get more or less marks from anybody in there. But it works. And if you're comfortable doing it, I would never have recommended this at the beginning of this course or even at the beginning of the conditional statements unit, because there's so many opportunities to make mistakes when you don't use those curly brackets. So I don't recommend it for everybody. But if you want, you can leave your code like this. And for some, this might actually be an easier way to digest this code, to look at it and see it in 5 lines rather than, it'd be, more like 15 lines with all the curly brackets in there. But you don't have to do that, right? So I'm just going to put that in as a comment, okay? Not using the curly brackets. No marks given or taken away, or not using them. Okay, so it's not going to affect your mark if you use or not use the curly brackets, okay? All right, so now let's go back to the big piece of code we got to write today. The timer code, okay? The timer code where we need to get the coordinates excuse me, of all 4 objects. Like we did yesterday, there's going to be some copy paste that's going to go on here. Well, let's start with getting current location. So where is Pac-Man right now? In other words, his coordinates. Where is Pac-Man right at this moment in time? And I know you guys could say, well, he's right there, right? Yeah, but eventually he's going to be moving around. So how do we get his coordinates? Well, Pac-Man's top coordinate equals the picture box of Pac-Man's dot top. Dot top was something you would have seen in the looping unit, especially if you did the rocket racing game. It's a way to measure that, the top of something. And I can also do that with left. Left. You might think, oh, okay, well, I'm going to do that with bottom and right. No, you're not. Okay. Bottom and right are different. But we'll start with top and left. So this gives you the top left corner of that picture box. Where is it in terms of an X, Y system? Okay. Now what I'm going to do is pay attention to Pac-Man's width. And for that one, I can do this. Again, you would have seen something like that in the looping unit. And I can do the same thing with height. Pac-Man. Height equals. Just putting in extra spaces to make it a little easier to read. Pick Pac-Man dot. Okay. Those four I get. The other two coordinates I calculate. This isn't really difficult math at all. Okay, it really isn't. Because think about it. I have top of where this is. If I know what the top is, it's right there. And I've figured out what the width of this thing is. Height, if I know the height of this thing, exactly how tall it is, I can just add those two together. Like, let's say this top position is position 10. And let's say the height of this thing is 30 pixels. Well, 10 plus 30 will give me 40, which is the spot where the bottom is. So Pac-Man's bottom equals Pac-Man's top plus height. It's a pretty simple calculation. And sure enough, we're going to do the exact same thing with Pac-Man's right. Pac-Man's right coordinate equals Pac-Man left coordinate plus Pac-Man's width. Okay. These are just basic calculations to give us all 6 coordinates of where Pac-Man currently is. He's currently at that spot. But now that we've done that with Pac-Man, I'm going to suggest we copy and paste that code because we're going to do the exact same thing with the ghost. And we're going to use that nice little shortcut I taught you to select the code, press Control H, I repeat, Control H, replace the word Pac-Man with the word ghost. However, notice that if I do this, there's times where there's a capital P and times when there's a lowercase p. So I'm going to have to be a little bit careful with this one. For this one, I'm actually going to turn on match case, this little button here, so that it only deals with the lowercase p Pac-Man. And then I'm going to replace them in the selection, right? So replace them all. Then I'm just going to capitalize these. Capital P Pac-Man, capital G. Oops. Let's try that again. Control H. In the selection, it shows me what it's about to do. And then I replace them all. Oops. I forgot. We called ours Ghost 1, Ghost 2. What did I do here? Dot 1 and Ghost 1, wall 1. Yeah, so it should be Ghost 1 top, left, width, and height. I'm going to go and actually key these in. That was a mistake on my part. I won't do it this next time. Okay, there we go. Oops. Okay, so Pac-Man's done. Now the ghost is done. And so now I'm going to copy and paste the ghost. Select the code, Control H, replace ghost with dot. Now this is good because it's going to be .1. So that's why I copied and pasted ghost instead of going back and copying and pasting Pac-Man. So I'll replace them all. And then I'm going to capitalize ghost and capitalize dot. Replace all those. And now the dot is done. And then one more to do. Copy, paste, select them, Control H. This time I'm going to replace dot with wall. See ahead of time what it's about to do. Place them all. And then go in and capitalize dot and capitalize wall. Okay, so I hope I went slow enough that you saw my process. Or if you're watching this back on video, you now can see how I went and got all the coordinates of all four things. Pac-Man, wall 1, dot 1, ghost 1. Okay? Now we're going to move on to part 2 now. We're going to move our coordinates. Okay? Move the coordinates. And okay. Fill my coffee cup. Take a minute. Make sure everybody is good, hunky-dory. And if you have any questions, feel free to put on your mic or email me afterwards or come in at the 3 o'clock extra help time today or tomorrow to get extra help. All right, my coffee is poured. Let's move on now to number 2, moving some of the coordinates. Now, the good news here is we don't have to move the wall or the dot. Potentially, we could move the ghost, but we're not going to do that. We're going to just move Pac-Man. Okay, so here's how we're going to do this. We're going to say, you know what? If Pac-Man's direction equals moving up. Pac-Man is supposed to be moving up. Some of these coordinates are going to change. Now, if you think about it, Pac-Man is moving up. His left and his right don't change. They stay where they are. But his top is going to change. It's going to go up like this. But also his bottom is going to change. It's also going to move up. So only when I'm moving up do I change the top and the bottom. So here's what I'm going to do. Pac-Man's top equals Pac-Man's top minus our move amount, the amount we'd like to move him. And that's it. Okay? I'm going to move him up a little bit. Now, what about the bottom? Well, for the bottom, I don't need to use the if statement for that. I can actually just recalculate these other two coordinates. So I'm just going to steal these from up higher in my code, including the comment, paste them down here after the if statement, and just change this to recalculate. I'm recalculating the top and the right. We haven't done the right yet, but we will, okay? Now, in addition, this is still just one line of code. So if you'd like, you can do what I did before, and you could move that up to this line like that. Okay? When Pac-Man moves up, his top equals his top minus an amount of movement. Now, I'm going to bring in an else if next, but I'm going to copy and paste. Else if, I'm going to add a few extra spaces here. If the movement this time is down, not up, but down, it's kind of the exact same calculation. What changes is the math operation I do. Now when I'm moving down, when I'm going this way, I'm going to add on a certain amount, not subtract. I'm going to add an amount like that. And really, that's how left and right are going to work as well. So I'm going to copy and paste. I'm going to say, what happens when I move to the left? But this time, I'm not changing the top and the bottom. This time, I'm changing the left. Pacman's left equals Pacman's left minus a certain move amount. And when I move to the right, I add. Let me just get this code cleaned up. You can actually see it's not as complicated as you would imagine. I mean, it requires you, to know what an if statement is, for sure. But this is an easy one to debug because I can just look at it and go, okay, for up and down, they're changing the top. Top equals top minus a certain amount when I'm moving up. Top equals top plus a certain amount when I'm moving down. For left and right, I'm not changing top and bottom, I'm just changing the left. And when I'm moving left, I subtract, and when I'm moving right, I add. And then the other two, top or bottom and right, I just recalculate. All right, so that takes care of number 2, moving some of the coordinates. And the coordinates are based on which key gets pressed. Now, what we're going to do for a minute here is we're going to skip number 3 for a second and go right to number 4. Because number 4 is actually really easy. It's just 2 lines of code. 2 is redraw Pacman on the form by saying pick Pacman dot left equals Pacman left. So the value that's stored in the variable is now getting put into the picture box. And we do the exact same thing with the top. Pick Pacman. Top. Pacman. Top. All right. The reason I wanted to do that is because now I can actually try it. There's going to be no collision detection. This won't work. So I should be able to go right through the wall. I should be able to go right through the dot and the ghost. I can even go right off screen if I want to. But let's see what actually happens. I'm going to run this thing. I'm going to use my keyboard, and let's see if the timer that's running is going to run this code and do all the little instructions we've been working up to for these last 2 days. But look at that. I'm pressing left, right, up, down. And Pacman is moving along. And I'm going to hit escape to close it out. Now, can I make adjustments? Sure I can. I can go into that timer, for example, and change the interval. We had just left it at 100 when we started this. Maybe I want it a little faster. Maybe I'm going to make that interval 1. So it's running as fast as it can, right? Every 1/1000th of a millisecond. Let's see what that does. Okay, that's up. Maybe he's a little too fast. Maybe he's too fast because here's another thing I can change. He's moving 5 pixels each time. Every 1/1000th of a millisecond, he's moving 5 pixels. Well, maybe I actually want him to move 1 pixel. So I'm going to bring the move amount down a little bit. That's a matter of finding that sort of fine balance. I'm going to sort of split the difference there and put a 2 there. Let's sort of see what that looks like. That's not bad. I'm going to go with that. It's pretty smooth. Some movement there. And again, there's no collision detection. None at all, because we haven't written that yet. But that's exciting. I can move things around. Okay. So that just leaves one last piece of our Pacman demo, the collision detection part. Fortunately, it's the hardest part. And what do I mean by hardest part? It takes some mathematical understanding to understand it, but also in terms of the actual code you write, it's pretty complicated, right? There's a lot of opportunities where you can make a mistake, okay? And what we're going to do is we're going to do collision detection on the 3 items, okay? So for example, we're going to check Pacman touching bot. Okay. That's going to be maybe one of the easier ones. Why? Because if so, Just make the dot here. Okay? All we got to do if we touch the dot. Okay? So it's not as complicated as some of the other ones. Let me bracket. If so, that dot disappears. Okay? Now, what happens when we check if Pac-Man is touching the ghost? Also is going to be pretty easy. If Pac-Man's touching the ghost, we're just going to end the game. I know that's not a realistic way to end this game, but obviously this is a mini Pac-Man. And we're going to leave the hardest one for last. The hardest one is the wall. So with the wall, if sorry, this should be if Pac-Man wall, okay, then we need to stop Pac-Man. Actually, let me put it this way. So dot, dot, dot. We stop Pac-Man. What does that really mean to stop Pac-Man? Well, it depends on which direction he's going. I don't want to say he, which direction Pac-Man. Okay. Pac-Man's going up, we stop him at the bottom of the wall. Pac-Man's going down, we stop him at the top of the wall. So there's a lot more to it with the wall, okay? But in each of these, we're going to start with the checking if they're touching part. And for that, we're about to write a really, really big if statement, okay? So it's 2:35, so we got about 10 minutes. I don't know if we'll get this all done today. And that's okay. We can then just move on to tomorrow's code. Okay, so I'm going to warn you. There's going to be a lot of brackets in this if statement because I'm going to try to combine a bunch of stuff together at once. Okay? So what you're going to see, like you would normally, but then instead of one opening bracket, you're going to see 3 opening brackets. Okay? This is like a complicated mathematical formula, right? Like, you know, like if you were like x equals, you know, y minus 2 times 5 plus 7 minus 8, and then that whole thing is divided by 5, right? Like, the brackets get complicated. Sometimes in math class, they'll change to different looking brackets. They'll like do this, right? So it looks a little different. And then they'll use like these brackets. Oops. But it's still gonna be a complicated formula there, right? In mathematically. So that's why I'm warning you, right? It's if 1, 2, 3. Okay. All right. Now, what do we do next? Well, we're going to say Pac-Man left is greater than or equal to dot 1 left. Okay? I'm just going to move that down so it's not showing up on the screen as much. Then after that, we're going to put the and symbol. So again, this is something that I said, you know, we may need, depending on kind of how complicated you want this to go. Games like this should only be attempted in a final project if you have been comfortable at this point in the course writing if statements. If you struggled in the if statement unit, I don't know if I'd recommend necessarily making a game like this, or partner with someone who's a little more comfortable. Remember, for the final project, you can work with a partner and you get the same mark. Anyways, so there we go. Pac-Man left greater than or equal to dot left, and Pac-Man left less than dot right, 1 right. Then you're going to have 1 closing bracket right there. 1. Not 3, just 1 of them. left, 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 right, Pac-Man, Pac-Man, dot. That's the way you can look at this. Also, you can see this is a greater than or equal to, whereas this one is a less than or equal to. This is a way you can sort of error check this. All right, now we're gonna, whoops, at the end of this line, we're gonna put the symbol for or. That's the symbol for or, right? Those two vertical lines. Right underneath that, we're going to put a single bracket, Pac-Man. This time we're going to go with Pac-Man right. But the rest of the code is pretty much the same. It's going to be greater than or equal to dot left. And so I'm just going to do a little copy paste. Pac-Man right. And then this will be the same. Okay. So there's another way to look at it. And at the end of this line, we're going to put two curly brackets. An and symbol. All right, so I'm just going to pause the video at this point. Not the video, but I'm pausing my screen capture right here. So that in the video, if you need to, you can pause this and sort of, you can double check by going, do I have 3 brackets there? Do I have 2 brackets there? Do I have an or symbol? Do I have an and symbol? Does it say right and right? Does it say left and left? Right, so you can kind of examine your code, all right? Then what I'm going to do is on the next line, it's going to be 2 opening brackets. And now it's going to be kind of the exact same code. So I'm going to copy it. Okay, so it's kind of the exact same code. But what I'm going to do here is put the 3rd bracket at the end. So it ends in 3. Okay, but I got to also make some other changes. So it starts off like it's the exact same code, but now I'm going to change all these lefts into tops. This becomes top. Changing top, left, switching those out. Left becomes top. And guess what? Right becomes bottom. Okay, adding in a few extra spaces. This, and well, let me put the curly brackets there. So this is what this if statement looks like. I warned you that it was going to be nasty, and it is. It's this nasty combination of things, but it's going to hopefully work. The logic on this and the math on this is something I can explain to you in more detail if you're interested, okay? Then the reaction, make the dot disappear. That's actually easy. Pick .1, dot visible equals false. This is code we started this code with, this course with. However, the thing about collision detection is it can get even more complicated if the 2 objects are of different sizes. And in this case, they are. Our Pac-Man and our dot are 2 different sizes. Because of that, we have to do what's called 2-way collision detection. We have to see, is Pac-Man touching the dot, and is the dot touching Pac-Man? So this is a little copy paste again. All I'm going to do is copy this whole if statement, paste it, okay? And I'm going to switch the words around. So instead of it saying Pac-Man here, it's going to say .1, dot left. And instead of saying .1 here, it's going to say Pac-Man. So I'm just going to do a little drag and drop switching here. You might think, well, should I just do a find and replace? Not yet. We're going to do that in the next one. And probably that's going to be tomorrow because we're running low on time here. But yeah, that's a good idea. It just isn't quite there yet. Just get this. Actually, I think And Pac-Man. Okay, so I will have to error check this in a second. Make sure it's laid out right. Put in the extra spaces. Just helps me see it if I have the extra spaces. Oops. Okay. Here's what this if statement, and by the way, I'm going to also make that an else if statement. Means I'm going to need some more spaces here and here. Okay, so here's what I see. This should all say dot, which it does. This should all say Pac-Man, which it does. And this should all say Pac-Man, which it does. Extra space there. I know I'm being picky, but Pac-Man, Pac-Man. Okay, good. Now, the next thing. Left, right, top, bottom. Left, right, top, bottom. Good. These ones should say left, left, top, top, right, right. Bottom, bottom, it should say. So I've made a mistake, and I've also made it up here, I now realize. I made a mistake right there. That should say bottom. That should say bottom. Okay, so that's how I can easily error check this giant chunk of code. Now, no, we don't have to write this all as one combined if statement. It is possible to write these as separate if statements, but it's even more code to debug in that case. Now, we're almost out of time today, but I'm going to do the ghost just so I can do both of these at once, because the ghost is also going to be pretty easy comparatively. All I have to do is take the exact same if statement over to here, and now I can do the find and replace. Control H, find the words .1, notice it highlights them all, replace with ghost 1, and I guess I don't need the 1 because there's a 1 in both of them, right? So I can just say dot, replace with ghost. And the Pac-Man stuff will be left the same. So I can just replace those all. And instead of making the dot invisible, I can just add a different line of code, the exact same line I did right here to exit this application when Pac-Man touches the ghost. Do it here, I'll do it here. And now I can test this code before we wrap up today. All right, here we go. Remember, the wall is not done yet, so I should be able to go right through the wall. And let's now try to touch that dot. There it went, it disappeared. Now we're about to go touch the ghost, and that should shut this program down, which it did, okay? And so that's where we're at, okay? It's some nasty stuff for sure, but it can be worked with, and if you've been practicing a little bit. All right, everybody. Tomorrow is our last remote learning class. We're going to finish this Pac-Man game. We'll do it quickly in the period. And then we can kind of decide as a group exactly what we want to do with it after that. So think about that for tomorrow. Email me if you have any suggestions for what we want to do tomorrow after we finish this. And if you need extra help, stay on Teams. If you have any questions, stay on Teams, or connect at 3 o'clock to the extra help time, or send me an email. And if you don't need any help, and if you don't have any questions, have a great day, everybody, and I'll see you tomorrow. Bye, everybody.
Bye.
See ya.
Bye, monsieur.